In this lesson, we'll be adding more information to each food item in our food diary app. We'll be adding the name of the restaurant where the food was eaten, and we'll add this detail view that will show details of a food item that we select. We'll also learn how to read and write saved files. This will allow us to save information between sessions of the app so that we can close the app completely and then run it again and still have all the foods that the user has added. The first thing we need to do is think about how we'll add and store this new restaurant name. Right now we have a food array variable that stores all our food names, and we could add a new array for restaurant names, but if we keep adding more data and having to add more arrays, that could get really confusing. The best way to handle this is going to be to group all the food data together for each different food entry, and then put all those entries into one single array. To do that, we'll use one of Apple's classes called NS Dictionary. An NS Dictionary is a collection of key value pairs. We'll add objects to a dictionary with a keyword or key. Then we can get the item back with that same key. So where we would add items to an array and get them back with the item's index, we can add items to a dictionary and get them back with the key. Here's how it works. Suppose you have two objects. One is a string, and the other is an array. You can create a dictionary with a set of objects and keys with the init with objects and keys method. Now we can get those items back later in our code by using the object for key method and using the key of the object that we want to get. So to get the string, we can type dictionary object for key special word. And to get the array, we could ask the dictionary for the object for the key list. So in our code, we'll make each food item a dictionary, and we'll add a string object for the food's name and then another string object for the food's restaurant name. Then we'll add that dictionary that holds both the strings to our food array. Let's do that now. Start Xcode and open the food diary project. We'll start in the TAD food table viewcontroller.m file where we first initialize the array in the viewDidLoad method. Let's create an NS dictionary and add it to the array. This can look confusing at first since everything is a string, but remember that the object is first, followed by its key. So we added the string object pizza with the key of food name, and we added the restaurant pizza place with a key name of restaurant name. We'll be using these key names a lot. To make our coding easier, I'm going to create some define statements for these keys. These define statements are like substituting keywords for code that's used a lot. They will allow Xcode to turn on code completion for these keys, and it will keep us from making a typo. Go to the .h file and add this under the import line. When defining constants, it's common to start them out with a lowercase k and our project prefix so they can be easily recognized when reading the code. Now, whenever we want to type food name, we start typing the names of these constants. Go back to our .m file and replace the explicit string with the definitions we just created. Notice how I can just type in a few letters and hit enter when Xcode highlights what I want to type in. This code works exactly the same as the code we had previously. If you want to keep typing the strings explicitly, that will still work, but this makes it a lot easier and it avoids mistakes. Now that we have the dictionary, let's add it to the food array. So now our food array is initialized to an array with one dictionary, but the rest of our code is still reading array objects as strings. We need to change that to make sure we're reading array objects as dictionaries. Scroll down to the cell for row at index path method. Change the code to get the dictionary from the array, and then get the food name from the dictionary. Let's also set up our cell in storyboarding so that we can have a subtitle in our cell with the name of the restaurant. Click on our cell in the food table view and select the subtitle style in the attributes inspector. Now back in our .m file we can get the restaurant name, and the subtitle style has a detail text label property that we can use to access and set the subtitle of the cell. Great, now the last thing that we need to do in the food table view controller is change our add food method. Instead of accepting a string as our new food, we want to accept a dictionary for the food. So let's change the method definition to accept an NSDictionary object. And we also need to change the method declaration in the .h file. Now let's go to our addFoodViewController.m file and make sure that when we use this addFood method that we just changed, that we're sending a dictionary and not a string like we were sending before. Scroll down to the addFood button pressed method. Instead of just passing on this new food string, we'll have to put in a dictionary and then pass the dictionary to the addFood method. We don't have a way to get the restaurant name from the user yet, so we'll just put in an empty string for now. And that should be everything. Let's see how that works. Great, everything looks good, except we need to be able to add a restaurant name in the Add Food View controller. Switch to the storyboard file and add a text field. We've done this before, so it should be easy. I'm just going to hold Option and drag from the text field we already have to quickly copy it and create a new one. Now add some labels so that it's clear to the user what each text field is for. Now switch to the Assistant Editor and control drag from the new text field to the code to create an outlet variable for the new text field. Call the variable restaurant text field. Now we can switch back to the standard editor and go to the .m file to add the restaurant name to the dictionary. Let's make sure that works. Great, now we can add the restaurant name and the food name for each new food and display it in the table view. And since we're storing everything in a dictionary, it's going to be easy for us to add more parameters to the dictionary later. Now let's add a detail view so that we can tap on these table view cells and go to the detail view to see the details for each food. Right now we only have food name and restaurant name, but we'll add more details to the food later. Switch to the storyboard file and drag in a new view controller. Now control drag from the table view cell to the new view controller and select push. Now let's add some labels. So we'll fill in these labels with food and restaurant names of the food that was tapped in the cell. Before we do that, let's make sure tapping our table view cell brings up this new view. So when we clicked on that cell, our app crashed. In the log, we can see that the reason was an unrecognized selector was sent. That means that we called a method on an object that object couldn't understand. It looks like we called the method setFoodTableViewController on a UI viewcontroller object. Now go back to our TAD FoodTableViewController.m file. The only place we set a food table view controller is in the prepare for segue method. Remember that we put this code here to set that variable in the add food view controller. But this method gets called before every storyboarding segue, so we're trying to call the method setFoodTableViewController in the new view that we just made. But that new view doesn't understand that method, and there's no reason for us to be calling it. So we need to check to see which segue is happening before we perform any actions in the prepare for segue method. An easy way to do that is to name the segues in the storyboard file. Click on the circle between the add food view controller and the food table view controller. In the attributes inspector, name the identifier add food segue. And let's name the detail view segue food detail segue. Now we can go back to our food table view controller.m file and use an if-then statement to check for the segue name in our prepare for segue method to make sure that we only set the food table view controller variable on the add food segue. In a previous lesson, we used the double equal sign to compare values, but we can't do that when we're dealing with object values unless we want to see if the two objects are identical and in the same memory location. But here we just want to see if the segue identifier has the same letter combination as add food segue. So we'll use the method is equal to string. This method returns true if the letters are equal, and then our if statement code will run. Now let's run the app to make sure everything's working. Everything looks good now because we're only calling the setFoodTableViewController method on the addFoodViewController. Now we need to create a new ViewController class to control the detail view that we just created in our storyboard. Go to File, New File, select a UI ViewController subclass, and I'm just going to abbreviate ViewController and name the file TAD_FoodDetailVC. Now switch back to the storyboard file. Select our new ViewController and go to the Identity Inspector and make our new ViewController's class TAD_FoodDetailVC. Now we want to connect these labels to our code so that we can have them display the food and restaurant names when the user transitions to this new view. Switch to the Assistant Editor. Make sure TAD_FoodDetailVC.h is showing in the code view, and Control drag from the name labels to the code. We'll call the first outlet Food Label, and we'll call the next one Restaurant Label. Now we need to have the food dictionary that was selected in the table passed into this view controller so that we can display all the information. Let's create a variable to hold the food dictionary. And let's switch back to the standard editor and select the fooddetailvc.m file so we can synthesize our new food property to create the setter and getter methods. We'll handle the setting of this food variable back in the food table view controller. So here we need to set the text of the food and restaurant names in the labels. This is something that we need to do every time the view appears, not just when the view is first loaded. So we'll customize the UI view controller's viewWillAppear method to set the labels. That method isn't already here, so let's add it. Since we're customizing a method that UI view controller already does, we need to call the method on the superclass before we do anything else. Now let's set the labels with the information in our food dictionary. Notice our code completion isn't working for the constant keys that we defined. That's because this file doesn't know about our food table view controller file where we defined our keys. So let's import it. Great, now the code completion is working. And now we just need to set our restaurant label. And now we're done with this file, but it relies on having the food dictionary to get information to set these labels. So we just need to make sure that we set the food dictionary back in the food table view controller before the segue to this food detail VC. And we'll do that in the prepare for segue method. Remember that we called the segue to food detail VC the food detail segue. So let's check to make sure that we're in the right segue. Now we need to find out which row is selected and pass the corresponding food dictionary from our array into the food detail VC. We can get the selected row from the table view with the index path for selected row method. And we already know how to get the correct dictionary from our array. And we also know how to get the view controller from the segue object that's passed into this method. Before we do that though, we'll need to import the food detail vc.h file into this file. Now we can get the food detail VC from the segway's destination view controller property. And we can set the food dictionary with the food detail VC's food property. Now let's run the app to see how everything works. Great, we can see the information update in the food detail view. And we can add new foods and also see those in the food detail view. The only problem with this app now is that if we close the app and stop the execution and then we rerun it, all the data that we added is gone. It doesn't persist from session to session. We need to fix that. We want to save the data when the user closes the app to send the app to the background. Right before an app is closed, iOS will send out a notification to any objects that want to be notified. If we want our food table view controller to be notified, we should register for the notification immediately when the view loads in the view-to-load method. First, we'll get the NS Notification Center. Normally we've been using alloc and init when we create our objects. NS Notification Center is a special object and we can just use the class method default center to get it. Now we can use the add observer method to add this food table view controller as an observer to the background notification. We put self for the observer object since we want this object to get the notification. The selector is the method that we want to be called when this object receives the notification. To indicate a method, we type @selector and then put the method name in parentheses. We'll type saveData, which is a method we'll define later. Make sure you include the colon after the method name. The name of the notification that we want is UI application did enter background notification. We want to know when the app goes into the background because that's when the user has quit using the app. If you want your app to work on devices without background tasks like the iPhone 3G, you might also want to register for the UI application will terminate notification. We can also specify that we only want this notification when it's sent from a certain object, but right now we don't care about that, so we're just going to put nil. Now let's define the saveData method to actually save our data when we get this notification. When you define a method that's used by a notification, it needs to accept the notification object. And let's also declare this method in the .h file. So this is where we'll save out data. In iOS, you can't save your files just anywhere you want on the file system. Every app has its own home directory called a sandbox, and it has to save everything in that sandbox. You can't access other apps' sandboxes, and other apps can't access your sandbox. We can get the home directory path with the function nshomedirectory. Apple recommends saving all user-generated files in the Documents folder of the home directory. So let's add on to the home directory path the Documents directory. Now we need our file name where we want to save our food array. Arrays are special objects that can be saved into files calledplists. If you have an array and each object in it is either an NS dictionary, an NS string, an NS number, NS data, or other NS arrays, then it can easily be saved to a plist with just one line of code. Let's name our file foods.plist. And now we can save our array with write-to-file atomically method. Putting yes for atomically means that our file will be written to a temporary location and then moved to the proper location after it's written, so that if anything goes wrong while the file is being written, our existing file won't be corrupted. So that's all we have to do to save our data. Remember that our array holds all dictionaries, and our dictionaries hold all strings. And since all those objects can be saved to a plist, we can use the write-to-file method and save the file to a plist. Now let's open the file in the viewDidLoad method when the app loads. The first time the user opens the app, the file won't exist. So before we open the file, let's check to see if the file exists. We'll do that with the NSFileManager object. Now we need to get the file path again in the same way that we got it in our saveData method. I could cut and paste this code, but if I wanted to change the file path in the future, we'd have to go change it in two places, which could cause bugs if I forgot that I had to change it in two places. It would be best if we created a new method for us to use that would get the file path. Xcode actually makes it really easy for us to do this. Highlight the code that gets the file path, and go to Edit, Refactor, extract. Let's call the new method plistPath. Make sure the new method button is selected and click preview. Xcode is going to generate new code and rearrange our old code to create the new method. But it will still have everything work exactly the same as it did before. Everything looks good in preview, so I'm going to click save. And you can tell Xcode to enable snapshots if you think you might need to go back to this point. Now whenever I need the file path of our saved file, I can just call the new plistPath method. And Xcode changed our saved data method to call the new plistPath method. Great, now I can fill in the rest of our code that checks for the file. If the file does exist, I want to read it into the food array. I can do that with the init with contents of file method. And if the file doesn't exist, I want to use our old food array with the pizza item. So let's add an else statement, and if the file isn't found, we'll set that as the array. And that's all we need to do to save and load our data. Let's run the app to make sure everything works. Great, all our data has been saved, and when we open the app again, it shows up. In the next lesson, we'll continue building this app and start using some of the features that make the iPhone unique, like the GPS geolocation. For the challenge for this lesson, try to add a new control and save the data for that control. Add a segmented control in the Add Food view controller that will allow the user to indicate whether or not they liked the food. Make sure to display the information in the food detail VC. And make sure to save the information so that it persists between sessions with the rest of our data. Don't forget that only certain types of objects can be saved: NS dictionaries, NS strings, numbers, data, and arrays. In the solution, I'm going to use NS string to save the data.